Happy Monday. How's it going, everybody?
It's going well. It's good to be here.
Yeah, welcome back from
Welcome,
New York.
Adi. Thank you.
Yeah, it's up in
Yeah,
New
it was a
York.
fun trip.
Hello.
Shout out to all my New York friends. I got to meet over the last couple of weeks.
That's awesome. Adi, for people who don't know who you are, do you want to give a quick intro?
Yes. Well, hi, everyone. It's good to be here with you Monday mornings or Monday middays or late evenings. My name is Adi. I am a VP of Developer Experience at Treeverse. I'm working on industry best practices for data engineers and also on market education, spinning different technical ecosystems in between the MLOps and the data engineering and machine learning engineering. I am also an O'Reilly author. So my book is now soon to be released in its final version on scaling machine learning with Spark and then bridging into PyTorch and TensorFlow, the distributed aspects of that, and how do we handle the data underneath in order to support that bridging in between different frameworks. What's more, I created the data engineers Slack community. We have a lot of interesting conversations taking place there on the ecosystem, the usability. We do a learning together in the open where we explore new technologies and new tools. And I'm super excited to join you all today and talk about, the latest and greatest and what are the challenges that we're facing and think through how we can get over these challenges together.
Sounds great. When is your book going to be published, roughly? What estimate have they given you?
So it's already on the O'Reilly platform. We're slowly adding more chapters to the online version. The printed copy should be at the beginning of next year, so
Nice.
January, February 2023. And this is, of course, after the whole operations of O'Reilly with grammar and structure and images, figures, all the good stuff that they do to make sure it reached everyone at home at the really high high production level for books.
Oh yeah, and your work is not over. I'm just saying, you'll get to read your book several times. What else? It'll be a lot of fun, though. I think so. Yeah, and if you're lucky like us, our book was supposed to come out. What was it, October? I think originally, and now it's already out. So who knows? You might have a early Christmas presents for people, or whichever. So, if it comes out sooner, so that'd be kind of cool.
Yeah, the O'Reilly team is great. They, at least in our case, they built some padding into the schedule, and then we got it done faster. And then their team moved really, really fast. And like Joe said, the editing process is brutal, but it's really exciting to see it get done and see, the final proofs in the printed book. So,
actually, we got one question here. We can get to data lakes in a second, but books are cool too. We can empathize. So Frank asked, "What animal is on the cover?"
Oh. Is that for me or is that for you?
No, that's for you, I think. So,
well, I can't really share. It's still a secret. So I saw my animal yesterday. It's pretty accurate. Let's put it that way. Yeah.
Interesting.
You can ask questions around it, but I cannot give it to you.
Are you willing to reveal any generalities of what type of animal or where it might live or anything like that? Is that acceptable?
Well, I can say that it lives in lakes, apparently.
That's perfect.
Yeah, so
it's a sea dragon. Speaking of lakes, I want to talk about data lakes today. Challenges behind data lakes. I guess level set with the audience. Still get this question often. What is a data lake?
Good question. So data lake is a collection of files. Basically, when we think about our file system, the lowest denominator there is we have a bunch of files. It can be, my laptop where I have a bunch of files. But actuality, what it is mean from a technical point of view, data engineers usually are using the cloud. And on the cloud, we'll have something called object stores. And object stores, we can relate to it as files. Basically, it's a huge file system that has unlimited capacity. We can save huge files individually or just small files, but big amount of them, and some combination of these. And then usually it turns into a data swamp, right? Because
does your animal live in a data swamp?
No,
Okay.
I hope not.
Okay. So what is a data swamp? I think it's a term that gets thrown out a ton. How do you define a data swamp?
So for me, the way I see a data swamp, it's basically when I have tons of files, but none of them make sense. Like, how do I know how to navigate in that lake, in that swamp, if there's no indexing structure, a way for me to work with the data lake? So for example, let's take S3, right? Let's take AWS Cloud. I can upload as many files as I want, but it will take me forever to go through the different hierarchies of directories and different files, etc. If I'm looking, like, let's say I'm looking for a specific file and it's not organized in a simple way for navigation, then for me it's a swamp, because I'm losing a couple of hours just trying to find a single file to take some action or do something. So this is how I define a data swamp: a place where I have to scan the whole data lake or my whole repository in order to find that one file that I need for some operations or workloads. How do you see it?
And I think specifically what we see is that once you have a data swamp, often people just never access that data. I don't know who coined this term, but one of my friends told me the term "write once, read never." Someone must have coined it a while ago back in the
The Warren pattern.
The Warren pattern,
Yeah.
which we have in the book we mentioned. Yeah.
Yeah, which reminds me of a sentence that people said, and I've seen it in a couple of tech conferences, like data is the new oil. Well, I don't think so. I think wisdom or insights we draw out of the data, can turn into a data product that we can later on productionize and build a business around, and not around the data itself, but actually, what's the insight and what that data means to our potential customers. Mm-hmm. I think that's also really interesting, and connecting to what you said of, I can write everything, but the question is, what do I do with it?
Well, we saw this often, I think, in the early days of data lakes, right? So kind of I would say the early versions of object storage, related data lakes were really, they're just kind of a mess. I probably created a couple myself. And so, and I think that the impression back then as well, it was, we're dealing with big data. So let's just make sure we collect all the data. No idea if we're going to use it. No idea what the use case is, but let's just make sure we, collect it. So it reminds me of those, I always say, it reminds me of those hoarders TV shows where people have like hoarding problems. And there's like a dead cat under like a piece of pizza that's been there for 6 years, and you're just like, well, I might need that someday. I don't know. So I'm just going to keep it. And so that reminds me a lot of what these early data lakes were like, or data swamps. So I think more of the fact. Frank actually has an interesting question here. Are data swamps necessarily bad, or are they data wetlands? I don't know. I mean, I suppose if you like that mess, you can keep it, but
I mean, I think it comes back to what Adi said, right? It's all about the insights. Once you start making sense of the data, then it's no longer a data swamp in some sense.
Right. So what are some of the challenges of data lakes then? And what are
Yeah, so that's really interesting. So we've seen that we are able to scale to exabyte of data, right? The cloud providers knows how to give us the object store, and the S3 on AWS or on Azure, we have Azure Blob. So we know how to scale. So that's not a problem. And we know how to fetch the data, bring it back. There is a metadata conversation on top of it. They also enables us, and this is a very big difference from HDFS, they enable us to update existing objects, right? So our objects now are not immutable as they used to be on HDFS, but they are mutable, which means we can go ahead and change specific files, and we can add rows or whatever we want to do with them. So we know we're able to scale, we know they are immutable. And now the question is, knowing that we have this large scale of data that we're saving, how do we process that? How do we make sense of that? So how do we take that data swamp into something that is actionable and profitable for a business? How we build that data product that actually creates the challenges here? Because we need to be able to model the data, right? Data modeling. Like what's the path? How do I define path of directories that are symbolic for the tables that I'm working with, for example? How do I enable multiple teams to work on the same files, knowing that now my data is mutable and can change under the hood? How do I add governance capabilities, knowing that I have all this data, it's spread, it's on the cloud. How do I make sure I'm adding capabilities for governance, like who can access it, the right to be forgotten? And so we kind of figured out the scale, but we haven't yet figured out, or we're working towards figuring out the manageability part of the data of the object stores that we have in the cloud. And I think that's this really interesting topic that is going to be with us for some good years until we'll figure that part out as well. And Charlie is going to be kind of a combination with our compute systems as well.
Interesting.
Well, one question I have, so you're very focused on data versioning, I believe. Do I understand that correctly?
Yes.
And so part of, I think one of the challenges you just mentioned that now we can like remove rows, add rows. We basically have what I'll call, some people have coined the term the data lakehouse, which means it behaves a bit more like a traditional MPP system. We can add and delete rows. In terms of data versioning, how do we deal with compliance issues? Does that mean we have to go back and modify our old versions of data and delete rows? Or can we be considered compliant if old versions are like stuck back in an archive somewhere that have data that people don't want us looking at?
It's a good question. I'll say the first, when we're thinking about compliance, we're thinking, hey, if we have multiple versions of the data, so one of the biggest examples is the GDPR and the right to be forgotten, right? So let's say I have some data of a user, of a customer, and they trusted me to give me that data, and so it's under GDPR compliance, and now then they said that they want to disconnect, they want to stop the relationship for some reason, and so they're acting on the right to be forgotten, for example. So with versioning capabilities, that means that we'll have to understand where is that user was in the system and kind of have capabilities to reproduce data that is as part of the user journey in our system and go back and delete it. So for every version that we have of the data, we need to be able, where is the connection point for that specific user, for that specific customer, and go ahead and delete that data. And I think reproducibility, the ability to understand where to go back to different versioning and of the data and actually understand where the user's data sits in is going to help us greatly, because up until now we had bunch of data and we had to do a lot of so we actually did a lot of versioning manually ourselves, right? We used to take snapshots of the data in order to run a couple of things, and so having it managed in one place can help us in that investigation process to act on top of it, and also add different scripts and different automations to do that. Because and like you mentioned, I've been working in the data versioning space for quite long, but data versioning is actually, it's not new. We have data versioning, and data engineers are practicing copying all their buckets and all their data multiple times in order to run their tests, and also in migrations when we need to migrate from, let's say, Spark 1.6 to Spark 2.4. In order to make sure nothing is there's integrity. So they're maintaining the data integrity in between the different versions. So they would copy it. So they will manually go ahead and copy all the tables on all the data that they have. So let's say they have 32 tables. So they will go ahead and copy all these 32 tables. And then after they're happy with the result of the compute, they will try to merge it back manually. And there are human errors. So statistically saying, it's probably 30 tables are going to be okay, and then on 2 tables we're going to mess up because we're human. But then with the GDPR and the compliance, there might be that we have missed on that copy mechanism that one of our data engineers did manually as part of the release process. which is one of our challenges. And so having tools that enable us to do data versioning in one space and kind of manage this whole experience and procedure that we do can really help us track, understand, and make sure we are adhering to, for example, GDPR and the right to be forgotten.
Now, is this data versioning, does this only apply to like structured or semi-structured data, or are you also incorporating unstructured data as well, like images, audio, video?
So in the industry, data versioning applies to all type of data. Specifically, the open source that I work on, it does data versioning at on binary files. So that means it can address structured and unstructured data together because it runs on binary and it's schema agnostic. But in the industry, there are different tools that enables data versioning that are schema driven. So they have a specific format where they have to have a schema. And so they will look at a specific schema and run versioning on top of that. So really depends on which tools we're using. Some of them are open source and some of them are closed source.
Interesting. Actually got a question here from I think Hyatt, I think is how this name is pronounced, with lots of punctuation. So versions, what about revisions? How do you manage that?
Revisions of the data itself or revisions? It's an interesting question.
Yeah. I think maybe, okay, so let's, without any context, maybe we'll talk about revisions to the data. So you did mention kind of the ability to update, delete, that kind of stuff. So maybe walk us through that. How does that work?
Yeah, I can walk you through maybe the experience of the open source that I work on. And this probably is going to be similar experience with other open sources that you work on, because the engine is probably similar because it speaks about versioning for the data. So it's similar to how we version source control. So if we have Git and we're using GitHub or GitLab, today we're able to branch out of our main branch of source control and really do some changes on our branch. And then according to some decisions that we make along the way, we can create a pull request and merge it back into kind of the main branch. So that can give us kind of a point in time in the whole workflow of, hey, we just merged this new update, so we can always, there's a commit address to it, attached to it, so we can roll back to the specific commit before and after that merge took place. So a similar experience, it's with the open source tool that I'm working on, and it provides a Git-like experience on top of data lakes. And so let's imagine that we have our main data flow running in production, and we want to branch out of that main data flow in order to run some tests or evaluate a new ETL or address schema changes and see if we want to merge it back into our main data in production. So it's exactly that, and we can, since we have that capability of branching out, we can commit that data, and this commit will keep a hash attached to it, so we can always go back and have this revision, so we can actually reproduce or roll back to a specific commit, specific time, a specific version of my whole data lake. So beyond just one table, it can be multi tables. And then I can merge it back into my production, which provides me another commit. So another place where I can always roll back to, before and after these operations on top of the data. And that provides me with revisions, because similar to Git, we can roll back, we can reproduce, we can find a point of time where the data was in the state that was good and healthy for us. So it's great for troubleshooting, and it's great for development, and it's great for everything that requires version control on top of that data. So pretty similar to how we work with Git. And then there are other tools that exist in the open source world, such as Apache Iceberg and Delta Lake, which also provide us with versioning capabilities on top of the data. The way they work is slightly different because they are attached specifically to tabular format. So they will have schema. And so the version control capabilities and the revisions are going to be for a specific table. So I can roll back, for example, I can travel back in time to a specific version of Iceberg table or a specific version of Delta Lake table. And so the tools, like the way I see it, LakeFS and Delta Lake and Iceberg are complementary because LakeFS can gives me reproducibility capabilities and version, because it has version capabilities on the whole repo and the whole data lake. So I can actually roll back in time to a point in an atomic manner to a point in time where all my tables were at a specific state. And there's also it complementary to these two tools because these two tools give me the granularity of traveling back in time only for specific tables when I need them. So that's really interesting way to do revisions when we were looking at the space of data where we have our whole data lake that has probably multiple tables at multiple states. Some of them are raw, preprocessed, materialized, depends on where we are in the data life cycle, which, yeah, give us these capabilities.
I got another question here actually from do you have anything else here?
Oh, I have another question. We can come back to it later. That we can answer a couple of other questions first.
Yeah, I wanted to strike a irons hot.
Yeah.
Actually a related question. So Jocelyn asks a quick question. So with the emergence of the modern data lakehouse architecture, what challenges does this present versus standard data lake versioning, i.e. updating the data catalog?
Yeah, so that's really interesting about what is, the modern data lake house is. So I just came back from the Data and AI Summit, and luckily they had multiple sessions on, what does that mean and how Databricks see the next wave of how we work with data in the industry. So the way they put it, they basically said we have the HDFS and Hadoop ecosystem, and then alongside it we have the data warehousing, right? Because we have different customers or different users that prefers the Hadoop and the open source ecosystem versus there's a great optimization that takes place in data warehousing because it's most of the times it's closed source. We can control the format, we can control the access, and there's a coupling in between the compute and the storage that enables us to do a lot of optimizations that are often missed where we need to decouple compute and storage. One of them is data locality, and if I'm running my compute and if my data is all in the same place. So when we're thinking about data lake, the big questions between how do we combine these two places is knowing that I have my Hadoop ecosystem, right? So I have my Hive Metastore, which is a big player in my Hadoop ecosystem, and I have my Spark Compute and all this world. How do I enable the capabilities of indexing and having data locality, for example, next to my compute when we're working with data lake? So the versioning capabilities are actually very complementary to these two, because in the data warehouse world, right, there is versioning capabilities. It comes from databases, traditional databases. The data versioning exists there. In the Hadoop ecosystem, we lacked this data versioning. And so a lot of data engineers will do a lot of manual work in order to maintain these versions. So if you're working with, for example, different, you're engineering your path, it might be that in the path of your tables, you'll see like V1, V2, timestamp, etc., that are translated at the end of the day, logically translated into the version specifically. So these two together are actually going to complement each other. And the big questions is around optimizations of the indexing that's available, and we are able to have at a very high quality level at the data warehouse versus in the HDFS, we are moving HDFS to the cloud. It's very much coupled with what object stores or gives us. And so the different open source solutions that we just discussed, like Delta Lake, Apache Iceberg, LakeFS, actually brings us closer into combining these two together and acting on the data lakehouse vision, which I think it's really interesting to see.
Okay, so here's my question I was thinking of, which is very closely related to the concept of the lakehouse. You mentioned earlier that schema management goes hand in hand with version history and that kind of management. Completely agree with that. Right now, the dominant way of managing schema is still the Hive Metastore, and the Hive Metastore is old. What are your thoughts on that? Do we need a replacement for the Hive Metastore? Is there something on the horizon with open source that I'm maybe not aware of yet that's coming down the pipe? And how should schema management evolve to better support data versioning as well?
It's a fabulous question. So just today we're having an offsite, with all the technical teams, and we're like clearing the dust of data engineering world and what does that mean. And we got a good reminder of the different terminologies and inside Hive Metastore. For example, you can use schema for the whole Hive Metastore, and that actually means databases, and you can use schema for a specific table. And so there's a huge complexity of language. But putting that aside, at the moment, there is no atomicity operations on top of Hive, right? Hive Metastore, putting Hive, there's the Hive compute part, and then the Hive Metastores that enables us to manage our data catalog. So there's no atomicity there. If we're running operations, it might be that the indirect link are going to get updated to the data where the actual partitions and my data is, and so I'll get access to all data sometimes. So if I'm running my Hive compute on top of that, and I want to access a specific file that I know was updated by a previous Spark job, it might mean that because my partitions have not yet, the links to my partitions and the files didn't yet get updated, then I'll actually see an older file, which is a big problem with Hive Metastore, and it's a big problem with, when generally thinking about, hey, I need to now spread my data across multiple machines. How do I have one state of the data saved in one place? So this is actually where data versioning is going to help us, right? Because if I need versioning for the whole thing, and I have an external kind of a sidecar architecture that helps me make sense of where the files are and where the versions are and things are got updated, then it can help me with that world. But to your question, thinking about the future of Hive Metastore, it's still an essential piece of the architecture for data engineers altogether. I don't know what will replace it. We definitely want to replace it. The terminology is old. The way we work with it is old. The challenges are still there. Managing Hive Metastore is always a pain. Finding the partitions and then include some of the files, and then running the repair operations in order to connect back the actual metadata of the table with, linking to the right files and where the partitions are, etc. I don't know what will replace it.
Yeah, I don't expect
Yeah.
it. No one seems to have an answer so far, but I have thrown that question out quite a few times because it seems like it's a question that's in the air, and our community just we haven't figured it out yet. So.
Yeah, I mean, who knows? Maybe it just stays around so long that it,
Can't
sort
get
of
rid
the
of it,
Lindy
like,
effect
yeah,
thing.
yeah.
Yeah, it's just. I mean, it's like a lot of technology too. I mean, nothing's perfect, but I will say that the shortcomings of Hive Metastore I would think would be alarming enough that people would be trying to work on something else. But maybe they are. I'm sure they are. There's enough smart minds in this industry working on everything under the sun, right? So for this to just be, oh yeah, this is totally fine. Let's just keep, I mean, that would be odd. So we'll see. I mean, then again, it seems to get the job done for now. So, but it seems like we're just hacking things on top of it more than Let me ask you this: Adi, if you were to wave a magic wand and you could start over with everything in the data lake, what would that data lake look like?
Wow. So I think atomicity of operations on multiple files together or multiple tables together is one thing that we're truly missing, because we feel like with Hive, where we try to access different tables that we just updated, but the links weren't materialized yet, and so we see old data. And there's a huge conversation. So for example, if I'm running my Spark job and my Spark job fails midway, there are still files that, got written to my data lake, but I want to be able to kind of clean them up before I'm exposing these files and someone else, like the next Spark job, is reading from them, for example, or even other compute reads from them, right? It's also a possibility. Yeah, so I think atomicity and the ability to manage the connecting tissues when I'm developing my data pipeline is critical here, and something that we work on as an industry, and hopefully we'll figure it out soon using different tools. But yeah, it's something that data lake itself doesn't provide out of the box.
I guess what's your impression? So I was working on an article this morning on sort of next gen data apps, so low latency data serving, kind of moving things back towards the application layer. But what are your thoughts on where the data lake fits into these data apps that we're now hearing about? It seems to be the new buzzword. So.
Yeah, so a lot of conversation on real time and streaming, definitely. If I understand, correctly, low, we want to reach a specific throughput. So my main question is, which ETLs are we working on? Because we have the ETLs that works on tables to enrich data that comes in real time, and when we need to serve the user in real time. But we still have this batch processing taking place to have this enrichment, to have these tables that are able to enrich in place. So I know there's a lot of conversation. I've read a great article by Uber. They actually shared how they build their architecture and how they're using Kafka under the hood for real time combined with different tools. They still have batch ETL processes running for different aspects of their machine learning, for different aspects of making decisions in real time. So basing it on data that they collected, historic data that they collected and computed. So aggregated or did some operations on top of that. So I think it's really interesting. I think these two, so batch and stream, or real time and batch, is still going to coexist. A lot of our compute is dependent on batch processing, on aggregation of historical data, and we don't yet have a solution on how to aggregate fast, like real scalable data set, even if we're deploying thousands and thousands of machine to serve the real-time processing. There's still a need that the aggregation is physics. At some point, we will have to do them.
Well, I like what's happening with Apache Hudi. I guess Apache Hudi is not brand new, and Apache Iceberg both, where they're designed to support more inserts and be columnar, like they hybridized row-based and columnar approaches, because that was always the problem with columnar. It's not good for like lots and lots of inserts. It just will fall over if you try to do that.
Physics.
Again, physics, yeah, it's just not optimized for that use case at all.
You got a question here from it's actually Ku. What's up, Ku? Can you share any experience in how metadata can or is currently managed in streaming data environment?
Ooh,
That's a good question.
Yeah, it's a really, really good question. I actually had a conversation about that with Gunnar. It's part of the BZM open source for the CDC, capture data changes. So mostly, like, there wasn't, mostly for CDC, so capture data changes, like what got changed in the data that I'm just now streaming into my system, so I can capture the metadata, like what are the files, what are the entries, etc. And also accessing the batch data that was processed before. But it's really interesting conversation. I don't know I'm not familiar with a specific use case of, where we need to, except for accessing data. So metadata, when we think about metadata, it actually gives us kind of a data catalog into where data is saved and stored in a distributed manner, right? So we have the partitions, and we have the actual files, and we have links, and we want to be able to, we have at least 3 duplications of each file. So for resiliency, purposes. So disaster recovery, such as if we lose one of the files. So it adds a lot of overhead into the way we work with data, because we need to save it into 3 replications and we need to index it. So we'll be able to find it and search for a specific thing and adding, more indexing on top of it for faster query if we have a columnar and we're looking for a specific column at a specific range. So that adds a lot of overhead, and in streaming, we're trying to stay away from that, right? So we see with streaming with Kafka, for example, some of the one open source tool that came out was the KSQL. So the Kafka SQL, so the ability to run SQL operations directly on events that Kafka is processing. There's also Flink, which tried to give a very lightweight MapReduce ability to streaming, but yet it won't process like the big data that Spark is able to process. Because how it works with has kind of a caching mechanism that has like they're holding a table in memory for caching of where we are, what's the data state, etc. So there's a lot of limitations around it, and then the big question is, like, do we need it for streaming so we can fetch the right data fast, so we can actually leverage all the indexing that we have and all the goodness that we have? The metadata can enable us to fetch the right files super fast, and then this is amazing. And I've seen the internals of Apache Pinot, actually, because their promise is real-time analytics. They do a lot of work behind the scenes in order to make sure they're kind of pruning the whole searching of the files in relatively fast manner to fetch specific files. But still, there's still work to be done around when we are saving these files. We want to save it in a way that it's fast, that provide us fast access and streaming in real time. Yeah, it's a long answer.
Oh, it was a good answer.
It's a broad question though, right? I feel like metadata is also one of these words that, I mean, there are many different types of metadata, and so we could talk about this for days probably. But it also seems to be one of these topics that the term metadata is being thrown around a ton. It's like, oh, we have to. Metadata is really important. Let's collect all the metadata. And it was our friend Raghu, incidentally one of the creators of Hive. He had this whole idea of a metadata first architecture, which we're kind of jamming on last year with him. So it's
although his version, I mean, it's exactly what you said, though. Metadata can be almost anything. So in this case, he was talking about metadata about when jobs were getting executed in dependencies, and then basically automating a lot of orchestration using that kind of metadata. But metadata can be schema. Metadata can be data about when data is collected. Just like when you talk generically about data can be anything. Metadata can be almost anything. Maybe one specific interesting question to ask on streaming. There seems to be this kind of open debate about what streaming schemas should look like and how you manage schemas, how you model. Yeah.
Oh, that's really interesting. So I'll provide my perspective, and I'd love to get your thoughts on it. And also, everyone watching us, please join us in the chat. I think it's going to be an interesting debate. So when I look at streaming, I look at events that comes into the system, and then there's some SLA. I have some contract for that event of, how fast that it needs to materialize and be served back to a customer, or we should take actions based on it, or materialize in an automated view, right? So this is like, at the end of the day, there is an automation taking place that is dependent on that event and how fast I serve it. So this is one point of streaming and real time. Another section that is going a little bit closer to the batch, but not exactly. It's more closer to the streaming and real time world. This is near real time. And this is when I want to have my data materialized relatively fast. So let's say in a dashboard, but I'm good with having a delay of like 2-3 minutes of the data, right? So this is like the near real time process where I'm saying, it doesn't have to be event by event. So I am able to kind of aggregate a small window of the data, kind of a micro batch of the data, do some aggregations on top of it, and materializing and send it to my my data customer, internal or external, because there's a human behind it or some automated process. It's okay with having the freshness delay of like 2-3 minutes. And then there is the whole batch. So if I want to be able to serve that specific event really fast, then that means that I'm processing that event and probably that event only. So if I need to enrich a specific row, let's call it a row, but I'm taking this event and translating it into a row, and I'm giving it a format, right? I'm taking my JSON, processing it, and giving it a specific structure, so it turns into an object that I'm running with. I might need to add columns to my object, right? I might need to make decisions. And all of that is going to be based on historic data that I have in the system and some logic that I'm running. So this is how I see, real time, where I actually need to operate in real time. And then near real time, taking in another step in, is actually the micro batch rate. Sometimes I need to even run aggregations on the fly for that specific data. So that enables me some delay in the freshness, some delay in the data, because I know it's okay to serve it after a couple of minutes. It's not exactly real time. And so when I'm thinking about these real-time applications, I always ask myself, what is the data architecture behind it? What do I need? What is the data modeling? Like, which part is actually real time? And this is where you all get in, and we'll have an interesting discussion, versus what is the data that needs to support that real time in order to make that to serve that as a data product at the end.
Yeah, it's an interesting. Geez, a lot to unpack here. Where do we want to start, Matt?
Well, I mean, that's a good. It is funny because I think in general that it's much easier to do real-time processing than it used to be, but there's still just a huge amount of immaturity in the space. I know Google has really pushed like Apache Beam, for example, which is supposed to solve some of these problems. My experience with Beam is that it's still immature in many respects, and there are still many basic features that it doesn't handle yet. And so I don't know. I haven't dug in enough to the future of the architecture. Sorry. I haven't dug into that architecture enough to know that if we're going to hit a wall with it at some point, it's going to have to kind of be refactored to solve some of these problems you're talking about. No. What are your thoughts, Joe?
I was writing about this over the weekend, and I had a LinkedIn post that's gotten some attention about data modeling, right? So it's something I kind of rant about every few months. I don't know, it pops up. Must be a seasonal thing. But it's like, okay, so tell me like the big advances in data modeling that have occurred in like the last few decades, right? Apart from Data Vault, which I think was the last evolution of things, there really hasn't been. I've seen some interesting people put some interesting links in that thread, but for the most part, there hasn't really been, I think, any significant evolution of data modeling practices. Meanwhile, there have been very significant evolutions of architectures and technologies. You mentioned streaming, you mentioned enrichment, right? This has no place in the world of, say, Ralph Kimball, for example. Zero. In fact, a star schema, try doing a streaming star schema and telling me how that works. Right. So there's a lot of questions, right? And so this brings up the notion of, okay, so like exactly what do you mean by schema when you're talking about it? What is the schema there for the utility of the immediate application, or is it there to have a sense of business logic and reference and stuff? Like these are different, seemingly different questions. If you ask people, actually, so I did this one. I asked many people who have invented a lot of these systems that we now use, big data architectures, and I asked, okay, so what about streaming and data modeling? How do you think about this? And the answer was, we don't. Plain and simple. Don't even think about it. We assume the data is correct from the source, and then we simply ingest it, maybe enrich it, and we move on with our lives. And these are people who have built a lot of the systems like HDFS or Google's systems and stuff like that, and that's just how they approach it. So it's a different philosophy. But now, I would say that this was also in a time when there just wasn't a lot of governance and they were using data lakes for all intents and purposes, but there wasn't the same sort of data management or governance practices that we're now talking about, right? And so it's a very open-ended, I guess, question and debate area right now. So hopefully there's a lot of traction. It's just because I like debates and I like progress. So anyway,
Yeah, and also think about the journey that new event takes, right? Do I write it to storage? At what step do I write it to storage? Is it only, goes over the network from one compute to the other, or it's only, one compute and then it's being running on one machine and one compute and then being deserialized, serialized and deserialized and material, being presented. So it reached the final stage. Like what is the life cycle of event in streaming?
And the argument with traditional data modeling practices is that if you try to do things like take an event and break it apart into multiple streams somehow, so that you have something that looks like a star schema, like the performance hit is just terrible. It's not going to be anywhere near real time by the time you're done. And yet at the same time, I feel like with data modeling, like Joe was saying, we might be kind of throwing out the baby with the bathwater, just saying, okay, we can't do it exactly the way we want to, so let's just forget about data modeling altogether. And that also doesn't seem quite right, because we saw what happened with Hadoop, where in the early days, everyone argued basically, oh, you don't need data modeling anymore. You don't even need schema. And then within a few years, we saw the necessity of bringing all of those things back. And so where are we headed with streaming now, and how do we solve these problems?
Well, data lakes in general. Yeah. So I was writing about this over the weekend. I've been kind of working on need to let Matt know about this. Maybe a new book on data modeling. But the whole notion is like it's maybe we need to rethink the entire notion of this, right? Of data modeling. Maybe we're actually asking the wrong questions and trying to apply the wrong techniques into a world where data is now very heterogeneous. You have unstructured data, various types. You have semi-structured, unstructured data that arrive at different velocities. And so the question really is, the old techniques wouldn't work on unstructured data, for example. There's no star schema for like images. It doesn't make any sense. It'd be just crazy talk. And so how do you come up with maybe a unified way of looking at your data, in a place like a data lake where there are different types of data that are somehow all there to serve the purpose of an organization, right? And so this is, and that have maybe, cross-sectional domains and so forth. This is, I'd love the audience to chime in and provide the answer for me right now, or you can do the same thing. But it's something that I'm just mulling over because I'm just weird like that on weekends. But yeah, it's an interesting question. But things like versioning, though, right? I mean, this is actually a really good step forward, because at least you provide like some sort of coherence amongst all your data, which didn't exist before. And I can, point time travel back to things and so forth. So it's interesting.
Yeah, and I really love, in your book, and this is a call out if you didn't yet get the fundamentals of data engineering, please do. It's a great book. Here it is.
I have to go read your book so I can recommend it, by the way. I'm going to go look at the pre-release chapters shortly.
Yeah, same.
Thank you so much. So I really love how you describe the data lifecycle aspects, like, what does our data, like, what are the different stages that our data go through, until it's materialized. And I will recommend, maybe if we can, so I would suggest trying to change the way we look at data. We usually look at data the way it gets into the system, and immediately, it's raw data that we get and we aggregate it forever, like you mentioned, and like we discussed in the beginning. But if we can change our perspective on data and say, okay, I have a data product, and now I'm looking at it from the lens of the actual end result, how would that impact the way I work with a data lake? What do I need in order to serve that data product and start working from the end? Kind of, we're engineers, so we love doing reverse engineering to things. So looking at the end result, looking at the requirements for my data product, and then think how we can build our data architecture, how we can build a different transformation that we do on top of our data, to make sense out of it, and not the other way around.
I think it's a good notion, and I formerly worked as a software engineer, and when you write software products, you really don't think about the architecture. You think about the need, and then you start focusing on the architecture behind it, i.e. like a software product, which is, I'm glad you bring up data products. This is something where it's another phrase which I hope more people think about, and not just think about and talk about, but really I think digest and so it becomes second nature. Because at the end of the day, we are making products, right? I mean, so.
And I think the tension with data products is, to what extent do you focus on structuring your data, on modeling it from one data product, versus, on the other hand, making it more general purpose and saying, okay, here's one application of this data. I know there are going to be some more down the road, so let's make it a little more flexible. And I feel like the early HDFS approach was like, okay, just focus on exactly what the product is. At least that's what Google was doing, right? Like
and it worked pretty well.
It worked pretty well. Like they needed to do page rank, they needed to process logs. So behind the scenes, they had very, very specific applications. People kind of took MapReduce and ran with it and did other things, but Google was very interested in specific applications. And then on the other extreme, you have like Kimball, where you're like, no, this is like a highly, highly prescriptive
That's
way of
become
modeling.
more like a religion now, though,
it is kind of a
right?
religion. Like, we have to make the data as general purpose as possible for any possible analytics that you might want to run on top of it.
Yeah.
But I definitely like more of a product approach. Go ahead.
Yeah, I'm curious, like, what's the cost of making it super approachable and more generic when we need to kind of justify, some of the things we work on? Because I see it as, it's an interesting debate. So from an engineering point of view, fun practice for sure. Like, how do I make sure my tables and everything that I work on is generic enough to enable everyone in the world fast access to any index or any query they wish to have? And that often means I will need to duplicate and have a deep copy of my data, or at least have multiple extensive indexes to enable fast query on all different permutations of a query that I can do to enable that feeling, that experience of a generic platform, versus if I'm focusing on building the architecture for my specific data products, then I see it as a more agile process of starting with one data product. So building the architecture, I know what I need for that specific thing. I know my transformation, how to save it, the tables, and then I can slowly iterate it on it. And it might be that at the end, well, it's never the end, but after 10 years, I'll actually reach a place where I have a relatively generic data lake platform. Who knows?
Mm-hmm.
Yeah, no, one concept Joe and I have tossed around a bit is that not only do you have versions of your data, but your schema can evolve over time. Now, the problem with that in a traditional data warehouse environment was that if you change the schema, it would break a bunch of reporting. But you can kind of borrow an idea from the microservice world and say, we're going to have, in the microservice world, in many cases, you'll have multiple versions of a microservice running at the same time until you detect that there's no traffic to an old version, and then you just basically let it die. And you can almost do something like that in a modern data environment where you have multiple ways, basically multiple data models. You kind of have older versions. And once people stop reading from those tables, those versions die. But it's basically table versioning as opposed to just data versioning and then schema versioning too on top of that. And so as a new product idea comes along, you can say, all right, we need to change the schema to do this, keep the old versions for a while.
So
until they're no
just
longer
like
needed.
API endpoints.
Like an API endpoint, yeah almost.
Yeah, it's so this is in the Data and AI Summit, they released Delta Lake Schema Evolution feature. So in Delta 2.0, it's already open source. And what they do under the hood, when you look at the code and the feature designs, etc., they hold kind of a set of rules, right? So they will mark if a schema got changed, or if I need to add some default value to a specific column. So if my schema does evolve with time, and now I need to look at an older snapshot, like my code is actually, wants to consume a new column, the new column that I added. So let's say I added a column in 2022, but I want to look at data from 2020. Then Delta Lake under the hood would use the rule that they have, and will give kind of a default value, so they won't break the schema, and the schema would be able to have their evolution with code, because we do know schema changed with versions. And it's always easier to add more columns than delete columns. But having these set of rules and capabilities enables us to keep track of what actually happens. So if we're fetching older data, we'll still have it in the relative in the new schema only with default values. So schema evolution is a big thing, and I think if I'm not mistaken, it comes from the fact that we want to programmatically digest new JSON and new structure of tables. So we want to enable the schema that changes on the fly, so we won't have to go back and manually or create a whole new table just because one of the columns got changed. So it's really interesting, and the way they do it, they baked in a set of rules into the metadata in order to do that. I don't remember exactly where they save it because there is the log file. So in Delta Lake, they save a log file into the file system. It might be there. It might be a completely new file, but it's definitely interesting. It's definitely something that we see, especially when we need to run versioning on top of tabular data, right? So we're holding the table. We know what the columns are. So at that point, it's really interesting.
That's fun.
Yeah.
It's such an exciting time, though. I mean, again, I think it's really cool that these discussions are happening and these innovations are happening. Like, it just, I'm very curious to see where things go over the next few years. And
yeah, and the tools and philosophies feed each other. We definitely have a lot of work to do on data management, on team management, organization between like application teams and data teams. But you do have this virtuous feedback loop between new technologies being developed and new approaches to management.
But these were discussions we were having a few years ago.
Yeah,
right? I mean, everyone's like, "Oh yeah, I just want to like do cool stuff with data," and I guess drive fast, live dangerously. So
yeah, but now I'm stuck with that legacy code and the Hive Metastore. It's still
it's
around for for 20 years.
But I want to do the cool stuff, but I can't. Right?
I guess we're all sort of like aging rock stars now. It's just awesome. Adeeb, back to the book you're writing. I mean, do you want to tell the audience more about that? I know we kind of touched on it in the beginning, but some of the people may not have joined at that time.
Yeah, I would love to. So my book on scaling machine learning with Apache Spark, and then bridging into the beautiful world of PyTorch and TensorFlow to, create a set of tools for data scientists to take advantage of the different areas of machine learning that sometimes are lacking, and the Spark machine learning is coming out in print in the beginning of 2023, already available on the Riley platform. And the promise there is, there's already the beautiful system that's called Apache Spark installed in a lot of our production systems. So how can data science actually take advantage of what already exists and connect to that environment and learn about the different capabilities that Spark offers for data scientists, and also, the different areas of I need to load data from Parquet. How do I work with it? What are the schemas? How do I design my tables to fit my machine learning experiment? All the way to production and deployment, and what does it mean to deploy machine learning as a service versus what does it mean to integrate it as part of my ETL and batch processing. It has a lot of examples of how you can take advantage of the different tools, and also some thoughts for the future on things we want to see evolve in the ecosystem, and sometimes what will make data scientist life much better when collaborating with data engineers and machine learning engineers.
That would be helpful.
So coming up soon.
That's awesome. What was your favorite part about writing this book so far?
The community. I mean, I got so much incredibly valuable feedback that made that book what it is. That it's just beautiful to see how everyone are willing to pitch in and provide their wisdom and insights, and they're very detail oriented, so they look at every word to make sure it's the right term. And I love it. It's really it shows how everyone cares and how everyone's support is going to impact and make, I think, is dramatically impact the result at the end of the day. So
I felt the same way with our reviewers in the community who helped us with the book. I think our book would have just been a shadow of itself without.
Absolutely true.
Yeah. I mean, it's cool to see people just come out of the woodwork and just support, what you're doing. Because reviewing a book is a lot of work. I mean, I'm currently reviewing one, Mal currently reviewing the same one, and it's so much work, but it's cool. I mean, I feel like you're contributing to something that's pushing the world forward. So hopefully your book does that too. I'm really stoked on it. And so, yeah, congrats. That's awesome. So actually Colleen just put a link here. So check it out on O'Reilly.com, pre-release versions. Should be awesome. So congrats. For people who want to learn more about you, Adi, how would they do that?
Well, more than happy to connect with me on LinkedIn. I'm available on LinkedIn, available on Twitter. On Twitter, I usually tweet some ideas and thoughts. On LinkedIn, you'll see all the live event that I'm doing and participating, and probably longer posts that I share. So these are great place to connect with me. And you're also most welcome to join, the Slack community that we have. And if you have any specific questions or areas, or you want me to review one of your future book chapters, send me a message on LinkedIn. I always love to collaborate and do things together.
Awesome. Very cool. Cool. Thanks. And coming up Friday, are we doing a show? Do we want to do a show?
That's a good question. Let's figure out what we're doing.
Yeah, I guess might do a show. Might do Matt and I. We haven't done a show together for a bit. Maybe talk about the book or something. Next Monday, we have Justin Borgman, CEO of Starburst, going to be on the show. That's going to be dope. Well, if you're in Utah Data Engineering Meetup.
Are we going to stream that? Are we going to get a camera or something to stream it?
I don't know.
Okay.
Maybe.
So maybe we could just do the same talk on Friday.
If you're in Utah,
it's very
show
free
up.
form today.
I think it might be a good way to do it. And then then on the next Friday, the 22nd, we got Gleb from Datafold joining us to talk about some awesome stuff there, data observability and stuff. So yeah, anyway, jam-packed schedule. So yeah, if you haven't gotten it, go get the Fundamentals of Data Engineering. You can get it wherever fine books are sold. You can also get it online at O'Reilly or on Kindle. So anyway, looking forward to your book too. Like I said, this is awesome. So great chat, Adi. Hope to have you on again. So
thanks, Adi.
Yeah.
Thank you so much, you two. It was wonderful to be with everyone here today, and I look forward to get a printed copy of your book. Hopefully soon I'll get it in the email.
Yeah, we'll figure it out. Yeah.
And someday I need to get to Tel Aviv. It's one of those cities I'd really like to visit.
Yeah.
Yeah.
Only if you like hummus, because then we can take you on a hummus tour.
Okay, let's do it.
Okay.
All right. Well, thanks to the audience. Great questions, great feedback. So see you all soon. Thanks.